welcome back on YAVA25 main stage. Now I'm with Johannes Bechberger, and Johannes will deliver for us presentation about debugging Unveiled and hidden germs. So don't waste our time, and Johannes, the stage is yours.
Thanks. I'm speaking to you from the lovely Karlsruhe in Germany, where it's also pretty cold, but without further ado, you probably all know bugs and you produce them daily, at least I do when I'm working. Here's one of the first bugs. It's actually a moth that flew into a relay and caused a mathematical error. So you see here, but nowadays we don't usually use the word moth for whatever reason, but we use the word bug, and usually we don't care about relays, but about programs. And to quote Edgar Dijkstra, if debugging is the process of removing software bugs, then programming must surely be the process of putting them in, and we're doing lots of programming, so we're doing lots of debugging probably. So consider this, we have a line count application, and what we expect is when we just count the code lines in the line count application, it returns 36 or something, because we surely have to code it. But the problem is, when we run it, it fails. There's an exception, and we don't know why, and we look at the code shortly enough so that you can glance it directly, because normally in large applications, it's really hard to find a bug by just looking at it. So the idea is we use a debugger, because debuggers are pretty helpful when you want to learn something about the code. So when we get to the code in our favorite IDE, in my case it's IntelliJ, we can just put a breakpoint where somewhere close to read and write failed. So we assume we just put it at the beginning of our main functions and check what happens here, and then we start our debugger, and we see, okay, we step over it. And then we see, oh no, file has the value code lines. And then we observe, okay, we just used the same, we just didn't use the correct argument for file. So we parse the first argument as the file, and the first argument also is like the mode. That's wrong. So we need to change it, and when we fix it, we can rerun it again and it works. So you see, debugging is well helpful. You can use it for much more. You can use it also for checking out the system's behavior, for adding logging on the fly, and so much more. Who am I to talk to you about debugging? I'm Johannes Bechberger. So right in the beginning, I usually work on something called profiles, and I work at Submachine. We're like one of the big open source projects of SAP. And we're the biggest, and we're one of the biggest contributors to the OpenJDK, and have our own JDK distribution. But what I want to talk about in this talk is about going down a rabbit hole in this next like 30 minutes. To begin with, I'll tell you something about general architecture and something about hidden gems that you probably don't know about in debugging, about the protocol, and later about conditional breakpoints, and how other debugger features are implemented. But to start with, how does debugging in Java works? Usually we take an IDE, in my case IntelliJ, but with Eclipse it's the same. So we go here, our IntelliJ debugger uses Java to talk to the Java debug interface, which is a simple Java interface, which then communicates with the target JVM that we're debugging using the Java debug wire protocol. It's a pretty arcane protocol, as we'll see in a minute, but it works. And this then it has an endpoint, the JDWP agent, and the JVM, and it's just a native agent that then uses the JVM-TI API inside the JVM to call the JVM function and make it happen. And that's all called the Java Platform Debug Architecture, because Java developers like acronyms. So then what's with VS Code? So there's no direct link between VS Code to JDI. That doesn't work that well, because there are some problems, as we see later, why it's slightly more complicated. to implement your own debugger, but what VS Code has, it has the debug adapter protocol and the language servers that implement them, or debug servers. In our case, it's a Java debug server, and this then calls JDI. And the fun thing is, that's based on the Eclipse debugger. So everyone who's using VS Code is essentially, when they debugging Java, is essentially using Eclipse, which is kind of funny. Because I think VS Code people are like, oh no, Eclipse is so old, and they're using Eclipse under the hood. But now on to some hidden gems. One thing, and remote debugging. One thing that you see when you want to do remote debugging, you can tell your IDE like, hey, please, I want to do this, and then tells you to put some arguments onto your JVM, essentially to configure the JWP agent. And what's cool with this is that there are essentially no differences between remote and non-remote debugging nowadays. So your debugger doesn't care where the JVM is on your system or somewhere else, and also your JVM doesn't care. Of course, we're assuming that you can open like a TCP connection between both, but that's pretty nice. And just recurring latency, of course. And now to a few little known gems. One is the on-exception debugging. So whenever you throw an instance of an exception the first time, and you specify which exception it is, you can start a debugging session, which is pretty cool. You just tell your JWP agent, hey, on throw of this exception, in our case X, please start the debugging session, and you can even call it to launch something. In our case, it's just exit because we don't want to launch anything, but you can tell, for example, on the first throw of X, start a debugging session and, I don't know, send an email, because it's a really problematic exception, and it's all built into the OpenJK because you can just call there any script you want, which is pretty nice. And then there's also the uncaught option, where you can essentially say, okay, whenever there's an exception that is finally uncaught, like not called by like your main method call, then you want to start debugging session in this instance, which is sometimes helpful because these kinds of issues can be hard to debug. And there are many more options. I can really recommend going to the JWP help page and checking it out. For example, the things for firewalls and other stuff. Now, let's go on to a short journey. Join me on a journey to a conference, because a couple of years back I went to Debuggers Belgium from Karlsruhe by train, of course, because I like trains. I was writing a blog post on this very topic that I'm speaking today on the train and other train stations, because I'm a nerd, of course, and I'm meeting some people loosely related to Java, just a few of the Java architects there. Anyway, and then I went to the Corretto booth because they had a problem. I found a bug. And now it's a mysterious bug, but it's not this one ladybug that I caught somehow caught in Antwerp and got to Cologne, but it's this one. So I was checking out the on throw option of JWP and trying it out, and it didn't work in IntelliJ. And I was like, why doesn't it work? Then I used the Java debugger on the command line, the JDB tool, and then I found out, okay, yeah, I have a null pointer exception inside the debugger, which I can tell you is not the best thing to debug, because then I had to attach the IntelliJ debugger to the JDB debugger to then debug the debugger. I can tell you, your mind is blown afterwards. But essentially, I filed an issue in the OpenJK bug tracker, because essentially there was a null pointer, because the exception object was never stored in like the on-throw event, and that was problematic and caused a null pointer exception. And yeah, I fixed it, and now it works with all JK versions. And that's the cool thing when you work at a team like Submachine, because I'm essentially paid to fix bugs in OpenJK, to make the life for everyone better, and that's very cool when you can just say, oh, I found a bug, and not like, oh no, I have to file a bug report and I have to tell some suppliers that there's a bug, but I can just like fix it directly. Yeah, and that's the cool thing with open source when you work on it. Then now to like one of the main parts of this talk, to the communication, how does the protocol works? Because the cool thing is the JWP protocol essentially explains you the feature, models the features that also the JVM has, the low-level features, because the mapping from JWP packet or request to JVM to I is pretty simple. So it explains you how things are implemented. So what we're talking about is the connection between your debugger on the lower level and your JVM. So this is a pretty old protocol. It's almost as old as I am. I'm not that old, no. But you essentially have requests and then you have replies with some data. And the problem is with this protocol, you need to essentially listen to the whole communication to get the next package. So you can't just drop in and listen. It would be garbage. But anyway, now let's see how a JWP connection goes from the connection start to the first suspend. So in the beginning, you have the debugger and it needs to know, hey, is this port that I'm talking to really a JVM? And so it tells the JVM like, hey, here's a handshake. And then the JVM is like, oh, I give you back the handshake. And then both know, okay, that's a debugger and that's a JVM. That's pretty cool. And taps. So what we need to have in mind always is that at the beginning, the shared knowledge is between the debugger and JVM is none. So the debugger doesn't share any knowledge with the JVM. Probably the debugger knows that we want to do some Java debugging, and JVM also knows that we do some Java debugging, maybe. But what we want to do, we want to combine this so that it later overlaps, so that the debugger knows most of what the JVM knows and the other way around. And that's the whole purpose of the communication, that we build this shared state. So in the beginning, when we touch the debugger, the JVM is like, hey, I started the VM, wanna play? And then the debugger is like, hey, yeah, please, but I don't know what your field IDs are size like and your method IDs, because these are essentially pointers, and because the JVM is platform independent but performant, so these pointers have different sizes, especially in the olden days where you had 32-bit and 64-bit architectures. Nowadays, you usually only have 64-bit architectures, so it's not a huge problem. But remember, this was developed in the 90s. So now we can parse the events that come, or the responses that come from the JVM. Then we tell the JVM, hey, please, every time a class is prepared and a class is loaded, I need to know it, because so the debugger knows which classes are available. And then the JVM tells it, and then tells it, yes, I tell you the next time. But then the debugger is also like, I don't know which version you are. Are you a Java 8 or Java 11 or whatever? The JVM is like, here I am. It's just good to know for debugger what's dealing with. And then, of course, the JVM has sometimes different capabilities, because, for example, it doesn't have to be an OpenJK. It could be different JK in OpenJK or something, in OpenJ9 or something like that. So the debugger asks like, hey, what can I do with you? And then in JWP 1.4, there came a few more options. So the JVM tells it, and the debugger knows what to do. And then the debugger in the beginning wants to know all the classes that were already loaded, because we can, were already loaded. So the JVM is like, here are some of the classes or interfaces. In our examples here, classes and interfaces are kind of the same in the debugging world, because nowadays, especially with default methods, they have also, except like having no fields, interfaces as really similar to classes. Anyway, then the debugger also wants to know, hey, are there any threads running that I need to know of? And then the debugger is like, hey, please, every time a thread starts, could you please tell me? JVM tells it, okay, you do. And then the JVM tells the debugger, like, hey, the main and the notify thread. The notify thread is something related to housekeeping. They're already started, and here are the threads IDs. And then the JVM is like, oh yeah, by the way, I'm currently preparing the URL class path file loader, like class path stuff. And then it tells the debugger like, oh, by the way, and I also loaded the line counter class in our example from the beginning. And then the debugger needs to know some information, especially because it wants to set some breakpoints. So debugger asks the JVM, hey, give me the line tables of the method. So that's essentially a mapping of the code index in the bytecode to the line number. So it can easily say, okay, I want to set a breakpoint at this bytecode index. And also, hey, please, do you know anything about what's the source file name? Because the problem is class files and source files don't map to each other because, for example, when he defines some inner classes, they have different class files, but they are in the same source file, so it's also important. That also means that you can technically debug JVMs where you don't have the source code for. And you sometimes do this when you see in IntelliJ, when you jump into an JVM internal class and it just says you, oh, I have this decompiled version. That's essentially how it goes. And yeah, and the debugger asks many more questions they don't want to list here. But then the debugger is like, hey, I set a breakpoint, and JVM is cool because JVM supports breakpoints. And now, while I drink a bit, do you have any idea whether there are runtimes that don't? Yeah, there are runtimes that don't support any breakpoints, which is a pity, but one of them is really used. It's called Python. You might have heard of Python, and especially in versions below 3.12, Python didn't really support breakpoints. Nowadays, it's slightly better, but not that much. It just improved the performance a bit, but if you want to learn more, you can read there in my QR code. I wrote a blog post on this topic. So we're really blessed that the JVM has a lot of debugging features built in. And yeah, then the debugger's like, yeah, please, JVM, go on. And then we hit a breakpoint. And the JVM is like, hey, by the way, I hit a breakpoint with this ID in this thread at this location. Please do something. And then the JVM is stopped, and debugger gets like the current frames and anything that it wants to show you, and then resumes, and then it goes on. And then eventually everything has to go to an end, and the VM dies. But does the JVM have to die? Good question. So who killed the JVM? Isn't the gardener? No, it isn't. It can either die by its own, or because the debugger told the JVM to just exit. Yeah, that's brutal, but the debugger can kill the JVM. So can we reattach a debugger? Good question. In Eclipse, it's pretty easy because in Eclipse, we have two options. We can either terminate the whole JVM to close the debugging session, or we can just disconnect. And JVM lives on, and we can reconnect. But in IntelliJ, we only have the stop button, which also terminates the JVM. But what we can do, we can click close tab, and then IntelliJ is telling us, hey, do you want to terminate the process remote? And then we have the two buttons. But the problem is when we click don't ask again, we've never asked again, so that's kind of a pity. It's one of the only cases where I find that Eclipse has a better UI than IntelliJ, but maybe there are other reasons why IntelliJ did this. Anyway, now on to conditional breakpoints. What conditional breakpoints are, you probably have used them before. You can essentially tell, hey, please only stop at this breakpoint if some condition holds true. For example, here in our count lines method where we ignore comments, we can add a breakpoint where we only break when the line contains a // for the reasons. But are there performance problems? Of course, when asked this way. The problem is the JVM doesn't really support conditional breakpoints, and with doesn't really support, I mean, it could have supported it, because when you look closely at the JWP specification, you see there that there is a modifier for breakpoints, and then called conditional, and it has an expression ID, but expression ID is defined no more. And yeah, it's defined as for the future. This was done like almost 30 years ago. Nobody implemented this, and nowadays with having multiple languages that go onto the JVM, it would be pretty hard, because you would have to have a kind of expression tree for every language. Kind of hard. So yeah, there's no support in JVM for conditional breakpoints, but you have them, of course. We can try them. How it works is they are emulated by breakpoints and evaluation. So how it works, let's just check. In the beginning, we have all the handshake stuff. I don't show it to you here again because it's just boring, but we then set a breakpoint at the line, and then the JVM is like, oh, I hit the breakpoint. And then debugger is like, hey, please give me the value of line, because essentially every debugger has a tiny Java interpreter built in. Please give me the value of line. Please create a string. Please give me all the methods of string, because I don't know anything about string, because it could be your own implementation of string. And then please invoke the contains method, where it give you like the this argument and the string argument, and it returns false because the first line doesn't contain it. We saw it here, doesn't contain any comment. So then we're like resume, and then we're doing this whole thing again and again and again and again, and finally we come to an event where we get a value of line, we create a string, we invoke the contains method, and then we get to frame, and then we're like, yay, we're done. We can now show and really break the JVM, not break, but suspend the JVM further. And now we get the frame and stack info and everything we want to show when we hit the breakpoint. And this also explains the breakpoint options. So this explains why we have quite a lot of options and quite a lot of things that we do here, because we can control a lot, because the IDE emulates breakpoints. But this, of course, also has problems, because when we have a high latency connection, that's hard. Yeah, but anyway, watches and eval expressions are implemented the same. Yeah, we just have a built-in Java interpreter. So conditional breakpoints are complex and slow, especially with large conditions. So how about VS Code? Is the debug adapter protocol better? Yes, it is, because here we have a condition that we can pass. We just pass a string, and this is an expression that we then evaluate. And the cool thing is, what we can do is, when we go over high latency connection, we can just put our debug adapter protocol server, like the Java debug server, close to our application in the cloud, and use the lower latency DAP protocol, because it needs less runtime. Yeah, but we're stuck with the JVM, and we're usually stuck with JWP when we use IntelliJ. So one of the best options here is extract methods, because we can essentially just have a method called condition there, and use condition here, and especially with more complex conditions, that's far faster. And we can use hot swap to update this, and essentially just put in our code at runtime, and yeah, it's far better. We can reload it, or we add a condition to the code. So now you might wonder whether methods with breakpoints are interpreted, and the answer is yes. They are optimized. That's that. Don't do breakpoints in like tight loops, but you shouldn't in any way do it because of all the latency stuff. And also single subbing isn't really good. The problem is the number of resources on this topic, like except this talk here in my blog post. Yeah, one. Like none, but there's one from Apache Harmony. The only problem is Apache Harmony was like a JVM related implementation that died in 2011, essentially a year after I learned Java, which is quite interesting. Now on to the last 5 minutes. So some more IDE features and how to implement it using JWP. Let's see how set specific value that you probably know. You have here, we're here. Oh no, the value is wrong. We set the value to some expression. We change this. Ta-da! We can run our code again. How does it work? Essentially, when we are at the breakpoint and we want to change the value, the debugger asks the JVM, hey, what are the visible classes? This essentially helps to tell what things we can execute here. And then what is the value here for args1? Because we, as before, we execute the code here inside the debugger, get the methods of path, invoke the method, and then there's a request called set sec frame value. This gets the value and sets it, and that's pretty simple. Then there's force return. Essentially, we can say, oh, please forcefully return from there with a given expression, and then go back up. And that's also simply implemented by the force early return request. The only problem is you probably know finalize blocks of when in the finally statement. The problem is, are they executed? And the answer is no. If you auto return, it isn't. So to quote the JWP documentation, no further instructions are executed in the call method. Specifically, finally blocks are not executed. So take care when you use it, especially when you use this feature in combination with some resource allocations. Yeah. So to summarize my talk or the whole debugging protocol, the debugging protocol is a cane. It's built in the 90s, you feel it. Nowadays, you would probably build it with some kind of protobuf or JSON or whatever, like debug adapter protocol does. But it kind of works. Everyone's adapted. Nobody felt enough pressure to implement their own better version. Because, yeah, why change it? It's supported by all IDEs. The thing is, it's also better than the ones of Python. And it's fast enough. And I made the same statement also when I gave at Python conferences, gave a talk on the Python protocol, and also told them like, hey, Java is better. No, if you want to learn more about how it works in Python, I wrote a Python debugger myself. You find it under the QR code. Just search for my name. And yeah, the protocol is also very versatile, which is cool. So to summarize, say no to complex breakpoints and keep away from excessive stepping and probably also remote debugging. It's all not that good. So if you want to learn more, you find me on Mastodon, you find me on GitHub, or I write every 2 weeks or so a blog post on something nerdy related to JVM profiling, debugging, and sometimes also eBPF. Find my team on Twitter at SweetSubmachine or at submachine.io. And if you want to rate this talk, feel free. And that's all from my side.
Okay, Johannes, thank you very much for your presentation. As Johannes said, you can rate his presentation using QR code or also using stars under the video player. Thank you very much, Johannes, for your presentation. Thank you all of you for participating in this session, and see you after a short break.